Okay, I'm going to get started. So thank you everybody for being there. Let me introduce myself. My name is Séverine Morin. I'm working for a SAGEM company that is part of SAFRAN group. And more precisely, I'm a member of a team, of a transverse team that is in charge of bringing technical expertise and support to software operational teams. And I'm glad to be there today to try to bring you visibility to the solution we developed. That is a solution based on Sirius Eclipse-based. It's an Eclipse-based solution based on Sirius. And that has a specific key mission that consists in trying to maintain a permanent consistency between specification that we write under DORS tool with the data model that we develop under Sirius. So it's really an industrial feedback, since this tool that we call Artist is currently used by a pilot project in SAGEM. So just a few official slides. Of course, I'm not going to spend a lot of time commenting it, just to set up the context of the development. So SAGEM, it's a company that addresses three core businesses: aerospace, defense, and security, with the largest part in aerospace. And it is constituted of several companies that are developing complex systems, such as engines for commercial jet or for helicopters, landing gear system, and inertial navigation system, and biometric system. So even if this kind of system seems to be really different, they have a common point, that is almost all of them are embedding critical software. And that's the point, that the way that we focus on to develop our software architecture modeling tool. So a few years ago, decision was taken to try to unify the different ways in the different company to develop software, critical software. So SAGEM has tried to implement a workbench, a software workbench named SYNCHRON, and Artist, that is the tool that I will focus on, is a specific tool dedicated on synchronizing specification data with architecture data. So we focused this tool on two key principles, what we call the correct by construction principle, which consists in adopting the principle of divide and conquer to try to break the complexity of system into small software components. And this induces the fact that these smaller components need to have interface consistent all during the refinement step of architecture and all during the different phases of development. So we focused our tool on this notion of maintaining the permanent coherency, consistency between the specification that are written under DORS tool for us and model-based that are developed for all that is architecture under an architecture tool based on Sirius Obeo Designer. For all these principles, correct by construction principle and also incremental principle, since the key is to, we know that we cannot do perfect the first time. So the key is to try to run a defined perimeter and to incrementally add feature to the component, but that requires also to master really strictly the architecture and the interfaces. So just a few slides to set up the different main constraints of our industrial context. So the safety constraints is really a prescriptive and needed constraint for us because we are developing aircraft and often software in aircraft, so it's a point. So that requires to have a traceable environment. That means that every code line shall be specified and shall be traceable until into the architecture. So we need to have an architecture workbench that fully integrates in a global environment made of homemade tools or codes tools, but that's a key, that's a point. We need to have artists shall be integrated into a traceability environment. So I will set which shows on there. The second point is that in aeronautics we are in a very normative and standardized world that needs requirement to be written in textual under textual tool. So we have chosen those for SAGEM. And we develop the model as architecture model until right now under paper, Visio. So we have a missing item to this workbench. So we have chosen Sirius to set up this piece. So we have a world of textual requirement on the world of model. So we need absolutely to create a gateway between these two worlds, since it's kind of obvious, but when you define a behavior of a software inside requirement, you need absolutely to have the data flow that are used inside the requirement test be the same that the one that are defined inside the model. So we need to set up a synchronization gateway between Sirius and the textual world, that is to say DOS. So on every stage of the development, from system specification to the different level of software specification until implementation. So we have also to be able, we want to be able to deactivate this synchronization for the main objective to have quick prototype means to be able to have an architecture that is defined at each refinement step, only a system specification, but always the feedback between implementation and specification. So we need to deactivate this synchronization gateway that we create. And then the reactivation as a plus-value to have the possibility to quickly have a specification with interfaces auto-created based on the model in architecture. So I have one slide just there after that presents the whole ecosystem of our workbench, and then I will switch on a few videos of demonstration, and rather than doing slideware, I prefer to show you the way that we have implemented artists and a kind of user feedback. So our ecosystem, it is that. So we have the DOS textual requirement with a specific database, and then you have the architecture modeling tool developed under Sirius. So we have developed web services based with a SOAP server and we use the Obeo Designer team server based on CDO to make this gateway between the world, the DOS environment and the Obeo environment. Then DOS fully integrates with the rectifier for all that is traceability. We can generate documentation with the tool named RPE from IBM. And then we based all our ecosystem under a normalized format that is the Recif format for exchanging requirement between the textual world and the configuration management. And then we have developed also the fact that the models are exportable in XML format, that let us the possibility to have a direct gateway with the implementation made under SCADE, Simulink, or manually coded. So we can generate model and code skeleton directly from the model and to re-import SCADE, Simulink model under Artist to reuse already developed architecture. So the question that is always asked is why Sirius has been chosen for your development. So we see the market, and as a lot of industrial, we ask us the question of must we reuse COTS tools, SysML, UML tools, and after that in fact, we need a simple solution because our request was quite simple to maintain a direct synchronization between world of specification and architecture, to maintain the consistency of interface. So we need a quite simple solution. But the codes that appear on the market didn't respond to our needs. So we observed that profiling cost of this tool was really prohibitive to address our needs. So the point is that Sirius meta-model structure is really adapted to make your own tools. That is to say, we have a software domain-specific language. We know our field domain. We know how to build a meta model that responds to our DSL. That's finally the hardest point. After that, the meta model structure is the mirror of our DSL, and then we can use Obeo Designer that is really adapted to our needs. And the fact that open source solution as Open API is JavaScripting, as handles normalized format is really a plus. And it extends the perspective to high scalability and interoperability for current and future tools. And the point is that Sirius is database centric. So we didn't want to have a file base centric tool. So the specification, the requirements that handles data flow, control flow, these flows are the same that are handled into the model. The database is the same, and that's a real point. So we have unique data sets, and then we can add different point of view of this data set. And then to generate different kind of documents, because every user has his idea of the document he wants. And another advantage is that Obeo Team Server enables industrial collaborative use, because we need in industry to share models between multiple users. So we need a server infrastructure that is provided by Obeo Team Server. And cherry on the cake, the license costing is really attractive. And we have also made some analysis and positive feedback. We had positive feedback of other SAFRAN division and other companies that are using already Obeo or Sirius to develop their system engineering solution. So for us, it's just for us the solution we developed based on Sirius. It's only a software architecture modeling tool, but there are positive feedback of other companies that develop their solution for system engineering. So I propose you to launch if we had time, three little videos. The first one is about the basic operation that we can do under our tool. The second one is more focused on this point presented today, that is to say the synchronization between Sirius and DORS. And if we have time, I will show you a third video about the import of SCAD already developed implementation into our tool. And after these three videos, I can give you the return of experience after months of development and conclude. So we cannot make the demo in live. I'm sorry about that, but we need a real infrastructure made of servers, so it was not possible for them. So the first point is how to create viewpoints. So effectively, our committed position is to provide the more simple tool set as possible. We take a quite real example made of a system that will calculate attitude, so people watch you, speeds, and so let's create the functional view. So we create a few components, of course, not all the inertial navigation system. So first of all, we only create a navigation data computation component with input and outputs. The outputs will be roll, pitch, and yaw. And we have adapted the HMI to our own languages, so you have range, accuracy, data that are typical to the domain. So there we develop structure data, that is to say we need, for instance, angular rates that are a structure of several integers. So we can populate the structure named angular rates with the three integers that correspond to x, y, and z axis measurement. And then we choose the type of data we propagate. And then you can see, you can propagate the whole structure or fields individually. On this example, we have chosen to propagate the structure, but all fields are also propagated. So we have developed two kinds of propagation. What we call the direct assignment, when only one architect is modeling, and the aliasing, when you are in multiple users on the same model. And aliasing, in this case, is a direct assignment, just to drag and drop propagate data. And the aliasing, you can directly make a correspondence between different data to say, okay, they have not the same name, but physically they are the same data. And then this was the functional view. Then we are going to create the organic view. So in software, it usually corresponds to partition. So we recover the feature that was created under the functional view, and we can propagate it and allocate to different organs. It's the same thing for the data. So the data that have been defined in the functional view are recoverable in the physical view. And the changes are automatically propagated from one viewpoint to the other one. And that's an interesting point for our industry that has really a normative. We need to generate data dictionary of all the data that have been handled. So it's interesting. And then, after a long while, we can create such a simplified navigation system. So you have the acquisition of inertial sensor, of external bus, application scheduler. You have the maintenance part, the computation part, and then the output emission with all the different features implemented. And then all these features have been allocated to different software partitions, so you can recover them. So that was it's embêtant. The first video. The second one is really centered around the synchronization between specification and architecture. So first of all, we need to connect to a server. So to have a shared project. To create our viewpoints, our specific viewpoint. And then we recover all the views that we have created before, so typically the functional view. And then we are trying to populate an empty DOS project. There is only the DOS inside, only the big template. And then we synchronize. And then you can see, as you can see, all the components are created. We have the snapshot from Sirius that is reinjected under DOS. And all the components have been declared. And then the components are there, and when you enter inside, as you can see, you have all the data that have been created under Sirius that is recovered under DOS. And then changing, for instance, the data flow name, we had roll pitch heading into roll pitch yo inside DOS. Only on synchronization. And then the data has been totally changed under Sirius, but aliasing is kept. That is to say, typically, you have two different developers. One is using the heading name, and the other has decided to change into yo. The data is the same, and the flow is kept. So we can also change attributes, domain fields attributes. for instance, we had an anemometric data that we decide to fill about the accuracy, the range. For instance, it becomes pressure variation, and we define several attributes. So it's a big pressure variation. And the synchronization, you can, as you can see, the pressure is there. And when you open the identity card through DOS, you recover the data you have filled under Sirius. And the aliasing is kept. And now what is interesting also that we can have this gateway between requirements, since our committed position is to keep the requirement management under DOS, but we need to synchronize the allocation to model through this gateway. So typically there we are written a requirement under DOS, so we have filled it. And just a synchronization, because we have written it in a dedicated chapter that whose title is the title of the component, then you can, as you can see, you will see, the requirement appears in the data in the requirement allocation table with the right component, and then you can change the component to which the requirement is allocated to, and just a synchronization, and then the requirement will move under DOS. So you can also create new feature under DOS, and then you will be able to see the component creation under Sirius. So typically, we need a time consolidation inside the maintenance component. Or for this case, we need to move the aircraft motion detection, the feature. So we just move it, we delete it in the first component. So as DOS is the master, the deletion, the purge is effective only on resynchronization. So after resynchronization, the feature has disappeared, and then it appears in the right component. So it has been moved. And the last feature. So we are going to create a new feature, totally new feature. And we are going to create a feature with input and output data. Typically a time consolidation that we need to have inside maintenance component, and then after synchronization, it appears. So the display is not. It appears there, and then the ports are populated with the data we create under those. Just the last video, about 1 minute, just to show you the concept of reusing already implemented architecture from SCAD model. So we have a SCAD model with a lot of input-outputs. And then the purpose is to extract this model into an agnostic format, in fact, into XML format. So we can, we have a parser to do that, an homemade gateway. And then we are able to re-import this agnostic description of component into Artist to create automatically a component from an already implemented architecture SCAD. And we can recover so the principle is the same for Simulink or for manual code. So, as a conclusion, so the return of experience for us is really positive since Sirius really enables to quickly develop our own workbench based on our own DSL. And the ratio between effort and gain is really positive too, because only with an initial training and an expertise support, we had acquired quick maturity and autonomy. And for user project, the fact is that our committed position to have a really simple tool made that the software engineer can really focus on technical aspect rather than on the tool handling. So it's a real positive feedback. And the fact to maintain by construction the consistency between specification and architecture has really a great value, because we have not anymore the splitting between specification from one side and architecture from the other side, and then a lot of issues during integration because the people didn't talk together. So in synthesis, effectively, Sirius can be an efficient solution to build its own workbench, even in industrial context. Thank you for your attention. Do you have any question? Yes?
Is the variability taken into account in your workbench?
Not at the present time, in fact. The variability, the reuse aspects are not taken into account at the present time, but we think about it, yes. Yes?
You talked about document generation.
Yes.
Are the document generated from the workbench?
No.
Using only modeling objects?
No.
Using requirements?
Yes. In fact, at the present time, we are using the IBM tool RPE that extracts documents from those databases only. But in future, we want to be able to really migrate into only the Reiki format, all the workbench into the Reiki format to directly extract documentation from the Reiki. We make step by step. Yes?
Maybe it's a secret, but how many times does it take to build this workbench?
It's quite a secret, in fact. It's quite, not a lot of time, in fact. Really, it's when I say just with a quick training, the team is like that. Huh? It's a real developer expert team. So we need to have experts in Java scripting, for instance. But we have developed this workbench is very few time. Okay. Well, thank you.